Okay, so we are to Unit 5, Lesson 4, Factoring Polynomials. And in the last unit, you'll remember we did some factoring of quadratics, so that's going to be applied in this, but we're going a step further from that and factoring polynomials that have a degree bigger than 2. So our first example here, finding a common monomial factor first. So that means factoring something out of each term first. So in part A, what I can do is I can factor x out of each term. So if I factor x out of each term, this becomes x squared minus 4x minus 5. Okay? And then we have a quadratic. So that's where we remember you can factor this quadratic using that strategy. Numbers that multiply to be -5 add to be -4. So that'll be -5, +1. So factored, keep x on the outside, x minus 5, x plus 1. Okay, x minus 5, x plus 1. So factoring, you might have to pull out a common factor first. In part B, we can pull out a common factor. We can factor out 3, and we can factor out y to the third. And the reason we can factor out y to the third is because if you think about it as a factor, y to the third times y to the second is y to the fifth. So it is a factor. So when we factor out variables, as long as they're the same variable, we factor out the variable with the lowest degree. So y to the third can be factored out. So this 3y to the fifth becomes just y squared. Just y squared. We factor out y to the third from y to the fifth. We're left with y squared. Minus, and then we think 48 divided by 3 is 16. And if I factor out y to the third from y to the third, it's just 1. So there's no variable left. So again, we can factor this. Numbers that multiply to be -16, but add to be 0 since there's no middle term. And that's going to be 4 and -4. So we have 3y cubed times y plus 4 times y minus 4. And that is factored completely. So combining GCF, factoring out a common factor, and then factoring quadratics, or factoring a trinomial. Okay. In part C, out of each term, we can factor out a 5, and we can factor out z squared. Because each term has z, we can factor out the lowest degree of z from those terms. So this becomes z squared plus 6z plus 9. So with that, again, numbers that multiply to be 9 add to be 6. They are both 3. So I'm going to show you how I want you to write this. It's 5z squared times z plus 3 times z plus 3. So that's really z plus 3 times itself. So a way I'd like you to write this is z plus 3 squared. Z plus 3 squared. So it's a little review of factoring trinomials, quadratics, whatever, but it's also that factoring out a common factor is an important part of that. So moving ahead, now this example, honestly, with this example, I'm going to expect you to use your notes to reference these two things, because I don't expect you to memorize how to factor a sum of 2 cubes. I want you to know what a perfect cube is, just like you know what a perfect square is, but factoring a sum or difference of perfect cubes is going to be extremely rare. So reference this whenever you come across that. So factoring cubes. I'm just going to show it for the sum, and then I'll show you an example. A perfect cube plus a perfect cube, the way you factor it is you take that cube of each term and you do that cube root plus the other cube root, and then you pretty much take these numbers, square the first term, square the last term, and then multiply the terms by each other. So I'm going to show that pattern in part A, and hopefully that kind of helps a little bit, okay? Because, actually, I'm going to show it right up here with the 64x to the third. So 64x to the third is a perfect cube, because 64 is a perfect cube, and x cubed is a perfect cube. Also, 1 is a perfect cube. So the way I would write this is, in this case, 4x is A and 1 is B. So I would write this as 4x plus 1, okay? And I would take that 4x and I would square it, so that would be 16x squared minus 4x times 1, which is 4x, plus 1 squared, which is 1. So essentially, once you find out what the a and b values are, you apply this pattern to the second factor, okay? So in this next one, the difference of two cubes. The only difference here is we subtract, okay, in the beginning. So in this case, 3x is A, 2 is B in this pattern. So we have 3x minus 2 times, this would be 3x squared, which is 9x squared, plus 3x times 2, which is 6x, plus b squared, which is 2 squared, which is 4. So again, this is a pattern. This is not something I expect you guys to memorize. That is kind of insane for me to expect you to memorize that. So I'm going to show this with the next two examples, and then we're going to kind of move on. So just use these as a reference. I'm not going to expect you to memorize how to factor special cubes like this. So in this one, if we think about these as perfect cubes, I'm just going to write out a and b literally. The a value is just x. The b value, the cube root of 125 is 5. 5 times 5 times 5 is 125. So the way we write this, since this is a difference, it's going to be x minus 5 times x squared plus 5x plus 25. So it's just following that pattern of a squared plus ab plus b squared. So you got to know what a and b are. That's what helps here, at least, with following this pattern, is deciding what a is, deciding what b is. Now in part b, it's not a perfect cube, so we're not going to jump to that right away. But in part b, I can factor out something from each term, okay? 16 does not fit into 54, so we can't factor out 16, okay? The number that we could factor out of each of those terms is basically 2. That's the only thing I can think of. So if I factor out a 2 and I factor out an s squared, I am left with 8s cubed plus 27, okay? Because all I can factor out is a 2s squared, but that helps us a little bit. So this 8s cubed is a perfect cube. 8 is a perfect cube. 2s. And then b, 27 is a perfect cube. It's just 3. So to factor this, I'm going to keep the 2s squared on the outside. And then on the inside, I'm going to have 2s plus 3. And then I have that pattern from the sum of two cubes. So it's going to be 4s squared minus 6s plus 9. So it's following that pattern. Defining what a and b are helps you follow that pattern more easily, okay? So your next example, okay, factoring by grouping. For this example, we basically, what we do is we group terms 2 at a time. So that means to group them, we put parentheses around them. So I'm going to put a parentheses around the first two terms, and I'm going to put a parentheses around the next two terms. Now, the main thing here is when we see this subtraction symbol in between. To preserve everything, I'm going to make sure this is plus and negative 4z. So really, to rewrite this, z cubed plus 5z squared plus negative 4z minus 20. I just want to preserve that addition in the middle of the two factors, or the two things in parentheses. And then we factor these each one group at a time. So in the first group, I can factor out z squared. So this becomes z plus 5. Okay, so I factored out that first grouping. In the second grouping, I can factor out 4. But what I'm really going to do, since they're both negative, I'm going to factor out negative 4. And I'm left with z plus 5. Okay? So this is the part that's tricky, all right? The grouping isn't as bad, and the actual factoring out a greatest common factor isn't that bad. This part is what gets people. So we've got to notice right here, we've got to notice that these are common factors, okay? So what we're thinking about is we're factoring out this entire quantity, z plus 5. So if I factor out the quantity z plus 5, what is left is z squared minus 4. Z squared minus 4. That's the tough jump we've got to make. And then when you think about it, we can actually factor this even more, because z squared minus 4 can be factored. I have z plus 4, or sorry, z plus 2, my bad. Z minus 2 to factor that completely. So that factoring by grouping, that's a little bit tricky, but the main thing is we group these together, two terms at a time, factor out a greatest common factor from each, and basically what happens is you know you're doing it right if whatever's in these parentheses winds up being the same two terms exactly. So that's a good way to self-check if you're factoring by grouping. Whatever winds up in the parentheses should be the exact same thing. So, my God, for this, I'm actually going to just separate this back into another video, because I'm already running on 12 minutes. So for examples 4, 5, and 6, I'm just going to make a separate video because there's so much ground covered in this lesson. So come back a little later in the lesson for the next video. I will try to do my best to not give you an overwhelming amount of practice, because there's so many different types of examples, but I'm going to target specific types of examples that I expect you to remember. So get a little bit of practice in, and then come back for the rest of the notes.